Where did Eric go?
Write him up.
He looked like scared. Where'd Zach just go?
He got scared.
I don't know.
He's crying because he raised your kids.
All right, number 9, there's questions. So, yeah, sorry I didn't do the answers. What's that?
This is my question.
All right, so before I even did the problem, I actually made y equals a little bit different, so I didn't use product rule. So I distributed the x to the 2/3. So maybe you have a mistake in your product rule, but it's a lot easier that way.
What is this for?
It's really random. So this is number 9.
What?
From last night, the worksheet.
Sure I do.
The worksheet. Is it on the camera?
Art spans terrible.
Is it like practice set 11 at the top or something?
Put that out.
What?
Art spans terrible.
Right? Like of a rat.
Yeah.
Ooh, pretty thing. Like, what the heck?
Tiny. I have a question.
Yes. If you did it product rule, it should be the same. Yes. So when I did it, I get 2x to the negative 1/3 minus 2. So I get 2 over x to the 1/3 minus 2.
Is this the worksheet?
Yes! Oh my gosh.
No, not this. That's not STEM. Do you have a copy of the worksheet?
Yeah, it should be in there.
I can't pay attention to that pumpkin in the background. I feel too festive.
One is really annoying. How was your great-grandmother's funeral?
We didn't know. My stepdad, like we woke up and then my stepdad couldn't move because he has back problems. So it was his grandma. So my mom was like, "You don't have to go to school." He's like, "Already not."
So wait, you didn't go to school, and you didn't go to the funeral.
Yeah, at least I'm honest.
Thug life. Thug life.
Yeah, Mike. You still didn't do your stats project.
I didn't mention.
If it were like, yeah, I killed him. But then he was like, at least I'm honest. Does that make up for it?
Yeah.
I'm really sorry. Does anybody have a worksheet that they're not going to use anymore? Like they did it last night and they don't need the actual worksheet?
No.
Did anybody do it last night?
Monica did.
But I wrote it.
The first one.
Wait, are you back?
Use quadratic formula. I just stopped.
Yeah,
That's literally where I stopped.
Wait, I got that, mister.
I'm going to teach to Monica then.
I got that answer. I got
Okay.
that.
So did you get then, you said the bottom equal to 0, you get x is 0, and the top equal to 0, you get x is, whoops, 0, you get x is 1?
Yeah.
Okay. So you make a number line with 0 and 1, and the second derivative,
Yeah, that's
well, if the first derivative is this, the second derivative is going to be negative 2 over 3x to the 4/3. Yeah? No?
not so much.
Because like if you bring the x to the top, I think you messed this up the other day, the fractional exponent derivative thing. Did you? So if you bring it up, 2x to the negative 1/3.
Can I borrow your stapler?
No.
No. Look, hers here.
You know what? Seriously? Of course. Right here. Oh. I think it might be out of sync. Camera. Are you the one who did you put sticky note? Oh no, you don't have the class anymore. What? The beautiful post-its like you did last year, but you're not in my class. Oh no. Did you get the derivative right now? If you go do it. So like 2 times negative a third is negative 2/3. X to the subtract 1 from that. So if your second derivative is wrong, that could have messed up the whole thing.
I didn't get to the second derivative because then I tried to do the thing again.
Doing what, the plugging in?
It was so sad.
What? Do you want me to keep going?
So you expect us to use the
That's good.
Not really, no.
So like the first one you gave us.
Yeah, it's, you don't really, like, it
Well,
wouldn't be
I
that hard.
did the product rule and I got the right thing. It just was really hurt my brain, and then I. Okay.
Do you want me to finish it?
Yeah.
Please finish.
Just finish.
My God, what is wrong with everybody today?
Just play music trivia.
Do you look at the first problem you gave us? So we got this one. This.
There's my number line for anybody who cares.
I care.
Concave down. Everywhere. So when you graph it, there's going to be a min here at 0, 0. And there should be a max here at 1, 1. Yep. So when I graph it at 0, 0, there's a min. At 1, 1, there's a max. To the left of 0, it's decreasing and concave down, so it looks like this. Then it's increasing and concave up.
Down.
Oh, right, down, sorry. And concave down, so it looks like this. And then it's decreasing and concave down, so it looks like
I
this.
have another question.
Yeah.
But why? Because that's not like an inflection point or whatever. Like, why does it change?
Because it's a fractional exponent.
No, like.
No, the concavity never changed. The concavity is concave down
Yeah, but
always.
it's like.
It's still a frown.
So like
I'm
the
still
second one,
frowning.
It can change direction.
it can change increasing and decreasing and still keep the same kind of concavity. Yeah. And that's why this is an important big moment. Why is this one a cusp and that one not? Where did this 0 come from? The derivative being undefined. Where did this 0 come from? The derivative being 0. Woo! Do you see?
No, I need to.
Whoa.
That's big. That is big. Where you see a cusp, you should be like, wait a second, let me check that. When x was 0, that came from the denominator of the first derivative being 0. Undefined. Quarter cusp or asymptotic vertical tangent line. This nice loopy one is from a horizontal tangent line, or the derivative being 0, and that came from the derivative being 0. What?
Do you frown?
I don't know how to frown.
Neither do I.
My world is made of marshmallows and happy.
This isn't happy at all.
Why are you mad?
It is to me. I'm actually just miserable.
Yes.
You make me miserable, but besides that,
Then I love you.
Number 6. We're supposed to do this without a calculator, so.
I didn't
It's
do,
about numbers.
I didn't do number 6.
Why not? You assigned it to us.
Yeah, I know. I didn't get a chance to do it.
You
Then
can
you can do it on the board right now.
No, because it's going to be boring.
No, it's not.
Taboo.
No, can you actually?
Number
You need to do number
6.
6 or let us do taboo.
Number 6 admittedly is a little more than you actually need to do. You could have graphed it with pre-cal anyway, so who really does care? I understand I shouldn't give you number 6, okay? I'll cry about it all.
Give us number 6.
No.
So I can cross it out now.
Cross it out.
So I don't have to
Zach?
do it.
Not done. What is that?
I'm
so much more
confiscating
fun.
this.
We're playing taboo.
Not playing.
If we have anything to do.
Taboo.
Let's go for a run.
Okay.
Let's
go.
Can we? I'll watch.
I will carry you on my
Idiot. I
back.
was doing like a workout. It was like a lame workout. I was doing like 400s, followed by 200 like slow. But my 400s weren't that fast. Like I don't know, whatever. The whole entire football team comes out. I'm like, really? I'm by myself on the track, like embarrassing.
No, they're probably like.
That is not the sum.
Yeah.
Okay.
Okay. So what we're doing now is not taboo.
Yes, it is.
You must have given us the wrong word.
It's graphing. Here's the thing with the AP test. Mac. Just kidding. They're not going to often give you problems like number 6 that Corey's talking about because they shouldn't be so nitpicky. They want to test you on the concepts. Sometimes the algebra gets tricky, but not that often. This is a perfect problem that they would ask you for because the zeros were so nice and so easy and easy to plug in. This would be the perfect kind of problem to get, all right, on a test that you take in here or on the AP test. But what they also do is stuff like this, where they take all of the arithmeticking out of it for you. Then they give you a ton of information and then they ask you to graph it. So number 1, let's take a look at it. They're giving you a whole chart and they're telling you what's happening with F, F prime, and F double prime on all these different intervals and at all these different spots. And then they got 3 questions, give any coordinates of relative maximums, blah, blah, we'll answer them. But what we want to do is graph this thing. So what they're really giving you is like a huge number line. And when I get a problem like this, sometimes I just make a number line out of it.
Like on the graph?
Like almost just separate. You don't have to do this, but I find the chart a little like tricky to read from because there's just so much happening at one time. What I find a little easier is to do what you're used to doing and make a number line labeled with the first and second derivatives and then the characteristics of F. Some of these don't go on forever. They'll usually give you a start spot and an end spot, so you're not graphing to infinity and stuff. And I might go put down, all right, -3, -2, -1, 0, 1, 2, 3. It's a lot of intervals to look at, and if nothing changes, we don't have to have that many, and some of the other ones there aren't quite that many, so it's not so bad. But what they're trying to tell you by this chart, I'm going to first use the first derivative line. And in the first derivative, they're telling you between -3 and -2, we have a positive derivative. Then we've got a negative derivative. We've got a negative, positive, positive, negative. So we don't know what's happening to the right of 3 or to the left of -3. That's where we're starting and stopping. So that tells us what's happening with the function, that it's increasing, decreasing, decreasing, increasing, increasing, decreasing. All right, it's also potentially going to tell us where the maxes and mins are. So if I look, since my graph changes from increasing to decreasing, what happens at -2? I've got a max. And I know where that point is. It's going to be at -2, 2. Because they tell me on here that when f is -2, the y value is 2. If I keep going, I change again at 0 from decreasing to increasing, which means I should have a min. At 0, -2. Blah, 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 and then at 2 it changes again, increasing and decreasing, so I got a max. At 2, 0. Everyone see what I'm doing? Then I go through second derivative and do the same thing. So I've got negative, negative, positive, positive, negative, negative. I'm just going to go put a D for down and a U for up. And we said every time that the concavity changes from up to down or down to up, we have a point of inflection. So here at -1, we have a point of inflection. At -1, 0. Here we have a point of inflection. God bless you. At 1, -1. And that's basically it. We also have a beginning beginning and a starting point ends at -3, and it starts at -3, 1. And then we graph it. Try to graph it and see if you get the same thing I do. You're never going to be able to tell how high up and down it goes. So you're going to have to just take some liberties with that. So I'm going to put the starting spot and the ending spot. I'm also going to go through and put all my other points. -2, 2, I've got -1, 0, 0, -2, 1, -1, 2, 0. This one is really pretty easy to graph. Even if we didn't do anything with the derivatives, we could probably figure out how to connect these points without messing it up. And the reason for that is that every derivative was a number. I'll go back and talk about that in a second. So let me go through, and I've got, this is like increasing and concave down, so I look like a frown. We're decreasing and concave down, so I still look like a frown. Now I'm decreasing and concave up, so I've got that point of inflection. Now I'm increasing and concave up, so it looks like this. Increasing and concave down, point of inflection. Decreasing concave down. Yeah.
Point -1, 0. The derivative of should be undefined. But they put 0, so it would be assuming.
The derivative. Oh, good point. Okay, let me go back to that.
Isn't between -1 or -2 concave down? Or is that what? Never mind. I mixed them up.
That's okay. I'm going to go to this question. Alright, so here's a really good question. So here's what you got to do. Once you finish and you think you've put it together, you want to go check out what's actually happening with the derivatives at each of these points. Because look at my -1 in particular. It could look like that, or maybe it actually looks like, let's see if I can draw this better. That. Like, maybe my concavity is actually, like, maybe it's actually,
Why would you?
well, like,
It can't. Unless there was.
how do I, okay.
Wait, doesn't that say like?
There would need to be a critical value there.
No, but look, here's, at -1, what's the deal? What's the derivative at -1? Oh crap, it's not 0, it's negative. Never mind. No, we're right, you got it like that.
Okay.
My point was supposed to be, you do have to check, because sometimes in the chart, in the first derivative line, it'll say a derivative is undefined. And in that case, you would have to exaggerate like a vertical tangent line here. There is no vertical tangent line at -1. Because what's the derivative at -1? Negative. Oh, we don't know what it is, but it's negative. So the derivative at -1, it should not be straight up and down.
Wait, so that's is that a negative or is that a no derivative?
Mine or on the chart? The chart is saying it's negative.
Okay. Oh, because there's a plus.
Yeah, because there's pluses or minuses. So I can't make this look like it's really like straight up and down. I have to like, I don't know, it's kind of hard to do, but this is not a vertical tangent line, and it's not because the derivative's not undefined there. When I get to another one, they're going to make it clear that the derivative is supposed to be undefined. That means it's either an asymptote, a corner, or a cusp, or it's a vertical tangent line. And I have to make it kind of clear that I have a vertical spot going on there. So let's do another one and see if we can make it clearer.
Okay.
Shut up. Like number 2, before you even start, look at the first derivative line. We've got an undefined derivative at -1 and an undefined derivative at 2. So at -1 and at 2, there's either an asymptote, a corner cusp, or a vertical tangent line. And getting the rest of the graph is going to help you know what it is. How do you know if it's an asymptote or not? What would be true about f of x?
Undefined.
It would also be undefined. So check it out. If at -1, f of x equals 2, f prime is undefined, what do you think's happening there?
Wait, what
Think
point
about
are
it.
we at? I'm confused.
On number 2, when x equals -1, f of x is 2, but the derivative's undefined. What do you think's happening?
Corner or cusp?
Corner cusp or vertical tangent line. At the x value of 2,
That's that.
f of x is undefined, and so is its first derivative. That's going to be the asymptote, because f of x is not defined there. All right, try to draw number 2 and see how it goes. This is more fun than taboo.
Not
It's
really.
a debate.
Not really. I'm having an awful time.
That's your fault. You guys ever had a donkey's cheesesteak?
Yes. Yeah.
That's what I'm having for dinner tonight. Can't stop thinking about it.
They're the best. Wait, you found them down.
They're amazing.
Almost got. I'm just kidding. I'll read this. Like more than that sugar tax. Between. That's mine. Two copies. This isn't hard.
Yeah, that was pretty.
You might make it more complicated.
Yeah, why do you even use? Yeah.
I don't know. Don't some people need it?
If you just
It's all right there.
The chart
follow
is a
the
number
up,
line.
down,
Alright.
increase, decrease.
Yeah,
it's a
you're
lot
so smart. That.
She's just getting irritated that we're smoking.
Last period.
Shut up.
Someone else.
Last period.
Son. Was he son? Shit, you're so angry. Son, sure with the hill. Simple. Sonny Wani.
What?
She just puts her head down.
Why? Put your head up. Don't you miss that chem class?
Not at all.
I don't think that's the
Does that look right to you?
Yeah.
Yeah.
No, right.
Okay, so we were specific about, this was the place where
Well,
you were supposed to have a quarter cusp. You do. This is the place where it's supposed to be an asymptote. Got it?
You do.
You do. Alright, try the third one. Oh my gosh.
Will you stop?
After this one, we'll stop.
Really, for real?
Yeah, for real.
You promise.
Unless you annoy me even more.
Inky promise. Alright.
I don't want to touch your pinky.
What?
I don't want to touch your pinky.
It's me, I promise.
I doubt it.
But the rest, the other fingers.